Hello, this is Mr. Stewart from Fossil Ridge Intermediate School bringing you the 5.5 homework quiz all about slopes and proportions on graphs. So we haven't really left this idea of proportionality. We're now just putting it on graphs so that we can understand proportions visually. And so this first question is reading and asking you, the graph represents how much money an employee can earn per hour. Doesn't that sound like a unit rate? Money per hour. Using the graph provided, match up the descriptions of each part of the graph with the letters on the graph. So we're not really asking you for mathematical calculations on this one. So in other words, a calculator is not going to do this for you. We've got each point is labeled in this red dot, and that corresponds to the number here, right? And finally there. So the question is, do you understand what you're looking at here? Well, let's just talk about graphs for just a moment. Most two-dimensional graphs are going to be labeled with an x-axis, we usually call it, and a y-axis. In real-world terms, we usually label x and y-axes with two different types of measurements, or two different types of units of measurement, and then we use that to compare. So, for example, an employee gets paid per hour. So the y-axis is representing how much the employee gets paid. The axis is representing how many hours it takes for that amount to be had. There's a relationship between the two of them. For example, if the employee only doesn't work at all, then the number of hours is going to be 0. So this is what we call the origin, this point where the x and y axis cross. We call it the origin. This is 0. Oftentimes, things can go below the origin. But when you're an employee, I hope that you don't have to pay money for working negative hours, although I imagine if you do mess up, you might have to be paying something. So the line is representing a linear relationship, a proportional relationship, right? So if an employee gets paid $10 for working 1 hour, that should be proportional to the same employee working the same quantity or the same for the same type of job getting paid $20 for 2 hours. So we would hope that that relationship is proportional. Proportionality will break when you do things like getting paid for overtime or time and a half for working on holidays or holiday pay, or let's say maybe you get a raise or a promotion, and so your pay before your promotion would not be proportional to your pay after your promotion. But let's just say this is just for 1 day, right? What are we looking at here? Well, this is, again, like right where you start with the origin. That's when your dollar amount is 0 and your hours are 0. So think about what that means. Think about what it means when you are working with a rate of $10 per hour, 1 hour. Okay, what type of rate is this? Okay, looking at this one, what does it mean right at this dot here? What are we looking at here? Well, look down. What does 3 represent? Money or hours? Look over. What do you think this person should get after 3 hours? How much? Okay, and then finally all the way up here, take a look at what this is corresponding to in relationship to the number of hours and the amount of pay. Like if you can figure that out, that's the relationship we're looking for. So you just need to line them up by putting A, B, C, or D into the column. So these letters into this column here. Okay. Okay. Question number 2 also contains a graph, only this time it's just a single question. This graph reads, the graph represents the number of pages a student can read per hour. use the information to answer the following question. How many pages can this student read in 1 hour? In other words, what is the unit rate? So you may use any point along the way. Like any of these points along the way will give you a rate of some kind of pages, number of pages per hour. Then you could just use division like you did in 5.1 to find the unit rate of pages per hour. However, conveniently enough, a rate is already provided for you in what we call an ordered pair. Ordered pairs have an order to them, and the order matters. So remember how in the last question I referred to this as the x-axis and this as the y-axis? We label it this way to keep things organized. X in the alphabet comes before Y in the alphabet. And so what you're looking at here is hours and pages. Like, that's important. So anyway, I hope that gives you the information you need once you set it up in a ratio form. Find the unit rate of pages per hour. And remember that order matters with unit rates, just like ordered pairs matters. So make sure you're putting it in terms of pages per hour and not hours per page. That won't give you the same unit rate. Okay, question number 3 reads, the following graph represents how many cans of pop you can buy per dollar. Use the graph to help you answer the following question. How many cans can you buy for $30? So this time we're given a rate and we're asked to set up a proportional relationship and solve for an unknown proportion. So if we're worried about cans per dollar, then we need to make sure we set this up as cans per dollar. So think about what you're looking at here. This is representing the fact that I can buy 4 cans for $2. So if I'm going to use this proportional relationship, then this is what it's going to look like. Cans per dollar. 4 cans for $2. So I'm wondering, when I have $30, if I plan on spending all $30 on cans of soda, how many cans of soda will I get? Right. And so let's see, we're looking at $30 cans of soda, like the proportional relationship, solving for this unknown. If you're not sure how to solve for an unknown proportion, go back and watch the 5.3 and 5.4 quiz video. That'll explain quite a bit for you. Notice how $30 is off the charts at this point. It's going to be somewhere out here, right? So the relationship is going to show up, as far as the graph is concerned, somewhere up here. But since we don't have this information, we're going to have to actually just use the math to figure that out. This last question is a multiple choice question. It reads, for every hour you work, you earn $12.50. So think about that first example. We're working with proportional relationships and a linear graph. This actually asks you to identify which graph best fits in describing this scenario. You've got several graphs to choose from here. In fact, there are 5 of them. And it's important for you to understand that, again, order matters and labeling matters. And so you can look at this graph here. Let's see. So for every hour, so it's $12.50 per 1 hour. Remember that, okay? So you would expect on this graph that $12.50 would correspond to 1 hour. And the fact that the graph doesn't cross at that point indicates some information to you. Okay, so you're going to use pieces of this information to help you with this. Okay, let's scroll down and look at a few of these. You've got, let's see, I'm going to go down, yep. So you've got this graph, B, that's reading, let's see, $12.50 per hour, $35 per 2 hours. You've got a graph that reads, let's see, $12.50 per 1 hour, but then after 2 hours, you earn, looks like $0. All right, so that's kind of weird. You've got 12.5 hours for $1. So if you're getting paid $1 for every 12.5 hours of work, I would advise you to find a new career of some kind, okay, or flee the country to a place that actually pays well. Okay, and then finally, you've got $12.50 for 1 hour, and then you get $25 for 2 hours. So it's up to you to decide which one this matches up with. But you're going to use logical thinking to interpret each graph. And so hopefully this is helpful for you without giving it away entirely. But this one's a little bit hard to talk about without, kind of giving it away. But anyway, hopefully this is helpful. Appreciate you listening. And have a great day. And don't forget to be awesome.